Good afternoon, everyone. My name is Ashish Acharya, a PhD student in Department of Computer Science at ODU. This is a course project for Introduction to Data Science and Analytics, and the title of my project is Spatial Analysis of Housing Price in Relation to School Proximity, a case study of Norfolk, Virginia. Here is the outline for today's presentation. Let's begin with the introduction. The core problem. The proximity to quality education is widely considered a key factor in residential real estate values. My project seeks to test and quantify this relationship, especially with Norfolk, Virginia. My three primary goals are determining the average home price with concentric distance zone around each school, establish the price trend as the distance from the closest school increases, analyze how this price trend varies based on the type and size of the school. The dataset I have used for this project are primary datasets: Norfolk Property Assessment Data, Parcel Boundary, Norfolk OpenGIS data, and the secondary dataset I have used are Norfolk School data from NCES, Great School Rating, and Needs grade are solely used for the purpose of evaluating the reputation of schools to see if the school that follows same trend in our analysis have similar reputation or ratings. Methodology: data preparation. In this step, I perform data collection, cleaning, and pre-processing. Cleaning the partial dataset, calculating the centroid and convert to the longitude and latitude, removing unnecessary columns from all the dataset, filtering the residential buildings properties from the property dataset, merging living area of data with the same LRSN values. This is a crucial step in our analysis because for this data to be consistent with our analysis, this is a crucial step. Feature engineering: add various features to the properties dataset for the analysis, such as price per square foot living area, remove outliers, merge property and parcel dataset to obtain the location of each property, classify schools into different types and sizes, geocode school address with GeoPy and ArcGIS. Regarding merging living area data with same LRSN, we will talk this about later. Distance calculation: mapping residential properties to the nearest school, preparing data for spatial analysis, converting the residential properties and school data frames to geodata frames. Ensure they are in same coordinate reference system for accurate distance calculation. Calculating distance to the school from each property, finding the closest school to the property, and visualizing the cluster as we can see on the right hand side of the slide, where each star shows the school and various color grades shows the housing property assigned to that school. Analyzing housing price by distance to the closest school. Finding the average price of the house as the distance from the school increases using both mean and median, and plotting the line graph as we can see in our slide. Overall, the price of the residential property increases as the distance from the school increases. Analyzing how the house price varies with type and size of school. Elementary, middle, combined type of school have slightly higher property values around its surrounding than the other type, as we can see in the graph over here. Larger size school have slightly higher property values around its surrounding than the median and small size school, as we can see over here. It is very slight increase. Examining house price variation around each school based on distance interval. The trends are increasing trends and decreasing trends. Analyzing if there is any common types or size or repetition of school that are in the same trend, but no any commonalities were found between the schools with same trends. Increasing trend means housing price increases with increasing distance from the school, and decreasing trend means housing price decreases with increasing distance from the school. Correlation analysis. Pearson correlation between distance to the closest school and price per square foot living area was found to be 0.2547, which is a slightly positive value that indicates that as the distance from the school increases, the price of the property increases. This is the opposite of what we have thought before doing this project. And T static value for negative, T static value also indicate the same, and P value, very less P value, also he says that it is not by chance, and there is a slight increase in the housing price as the distance from the houses increases. The result and key findings. There is essentially no strong correlation between distance to the nearest school and the home price per square foot area. The Pearson correlation between distance and the price per square foot was only about positive 0.25. This weak positive value indicated a very slight tendency for home farther from the school to have higher price per square foot, but the effect is extremely small. In practical terms, across the whole city, being closer to a school did not systematically yield higher home values. Home near combined elementary middle school had the highest average price per square foot compared to other type. Similarly, large school had slightly higher surrounding home values compared to other school sizes. Overall, this underscores that the local neighborhood characteristics, house size, crime rates, amenities, school reputation beyond size and type appears to dominate any proximity effect. To access this relationship, I used multiple matrices: correlation coefficient, category averages, distance slopes, visualization inspection. By combining these matrices, I thoroughly examine whether a distance price link exists. All evaluations consistently indicate no strong impact of distance on price. The challenges I faced during this project are geocoding limitations. When I use GeoPy for geocoding, it often hits the uh, hit, hit rate limits. And the problem with the GeoPy is it was not able to geocode all the schools addressed into longitude and latitude, so I have to use ArcGIS as well. Modern living area for same LRSN. Many records sharing the same LRSN represents multiple unit properties like duplex and apartments. This entries often list different living area values for each unit or apartment number, but they all share the same total property market value because they assess the value applies to the entire parcel or property. And this was the main problem during the initial phase of the project because I was not aware of this. The aware of the dataset was represented like this, and during the initial data expression, the very small living area values of individual apartment units paired with the large total property value of the entire building seemed likely significant outliers. It was only after investigating these cases in depth and noticing repeated violation with identical property name but different unit or apartment numbers, that it becomes clear to me these were not outliers but multi-unit properties represented at unit level. And another challenge is that for I faced during this project is school data consistency. The school dataset grade level formatting was inconsistent using PK versus some numerical grades wrote custom logic to classify school types correctly. And the biggest challenge was the local variability. I was not able to isolate the effect or so the effect of distance to the surrounding has an effect on the housing prices. In conclusion, I want to say that in summary, the data showed very weak signals in any direction. The hypothesis that closer to school is higher value is not generally supported, especially in this case for Norfolk, Virginia. If anything, the slight positive correlation suggests the opposite minor trend. But this is likely comforted by the factors such as older neighborhood being closer to the older school. The potential extension of this project includes add socioeconomic controls, multivariant modeling, predictive model, geospatial dashboard, cross-city comparison, apply same analysis to other Virginia cities to see if the Norfolk result is unique or general. Thank you very much. Thank you for listening. Have a good day. Thank you.